Next problem I'm going to do is number 5 here. We just got done with an unbounded region example, and then on those you either have no max or no min. Now on number 5, we're going to look at what happens when we get a bounded region. You'll see why we call this a bounded region here in a second. So if you notice again, we're going to have to get things in slope-intercept form. So we have x plus y, and I'm going to come down here. So x plus y is greater than or equal to 2. We're going to subtract x from both sides. So y is greater than or equal to negative x plus 2. I'm going to box that one in. Our middle one, we have 2y is greater than or equal to 3x minus 6. We're going to just divide by 2, divide by 2, divide by 2. So y is greater than or equal to 3 halves x minus 3. And then our bottom one there is 4y is less than or equal to x plus 8. We're going to divide by 4 to get it in slope-intercept form. So y is less than or equal to 1/4 x plus 2. Okay, so now we're going to have to graph these on the coordinate plane up there on the grid that I give you. So the first one, let me do a little maneuvering and make this a little bit bigger. We have y is greater than or equal to negative x plus 2. So positive 2 is my y-intercept, and we'll do that in red. So positive 2. And my slope is negative 1 over 1. So I'm going to go down 1, right 1, 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 down 1, right 1. You're going to want to repeat it because we're going to have to find vertices or intersection points. Okay, so we'll go ahead and I'm going to make it a little bit narrower line here for you. So we're going to go and, draw this line. I need to make that a little bit better right there. So there's that line. Now notice it's greater than, so I would be shading above. And I'm just going to wait to shade my overlap at the end. So let's go to y is greater than or equal to 3 halves x minus 3. We have negative 3 for our y-intercept. So we're right here at negative 3. Up 3, right 2. So notice that's where it's going to intersect our line that we already graphed. Up 3, right 2. Up 3, right 2. If I went the other way, I'd go down 3, left 2. Oops, I'm sorry. Let's undo that. I just made a mistake. I'm sorry. I'm confusing you. So we're actually going to go from negative 3 here. We're going to go up 3, right 2, so it would be right there where it intersects. Up 3, right 2. Up 3, right 2. Down 3, left 2. So this line is going to go pretty much like this right here. I made that one a little thicker, but that's okay. You can kind of see where they intersect. And that's greater than, so it'd be above. So right now I'd be up in that top portion of the V, but we'll wait till we graph our third line. If you remember, our third one that we solved is 1/4 x plus 2. So positive 2 is my y-intercept. Right here. And again, we are 1/4 for our slope. So I'm going to go up 1, right 4. So I would be right there. Up 1, right 4 would be over there. Down 1, left 4 would be there. So this line is going to come just like this. Okay, and now I have to have my intersection points. So our vertices, I'll make this red. Okay, so and that one I am below. So really my shaded region is going to be this portion right in the middle here. Right in here. So that's what we call our feasible region. So if you think about your coordinates of your vertices, they are going to be this point. Let's make this wider. I'm going to make these a little bit bigger. So we're going to have this point, and that point right there. Okay, and I made them extra big on this example. So our vertices, what are the coordinates of those vertices? We have the one on the y-axis, which is 0, 2. We have the one on the x-axis, which is 2, 0. And we have 4, 3. Now, this is a bounded region because it's totally enclosed. We basically formed a triangle. So if I go back over here, now I've got to take those vertices and put them in a table here. So we're going to make, again, a 3-column table. X comma y in your first one. Put in the function, in this case it's 3y plus x, that one goes in the middle column, and then what it outputs when we put those x and y values from our vertices in. Okay, so we have these 3 vertice values. We have 0, 2, we have 2, 0, we have 4, 3. Now we're going to go 3 times 0 plus 2, so that's 0 plus 2, that's going to output a 2. In my third column, this one is 3 times 2 plus 0, so that's 6 plus 0, which is 6. Then we're going to go 3 times 4 plus 3, so 12 plus 3, which will be 15. Now, unlike the last example where we had an unbounded region, and we only had 2 vertices, this one's got 3 vertices, it's bounded, it's totally enclosed. Okay? All we have to do is look at our column right here. We look at this column. The biggest value is your max, so our max would be 15. And our min is the lowest value, which is 2. You're maximizing and minimizing a function for a feasible shaded region. So unbounded, again, you're either going to have no max or no min, depending. When you have a bounded one like this, it's just biggest is the max, smallest is the min.